All right, here's page 2. Page 2, I have the limit as x goes to 0 of pi squared. Remember that pi squared is a constant. X can go any place it wants to. It's never going to affect this. This answer is just pi squared. Over here, x, evaluating the limit as x goes to 3. If you take a look, I'm worried about the bottom, but in this case, I don't have to worry about it. I just get 5. 3 plus 2 is 5. I plug in 3 to the top. I'm going to get 3 squared, which is 9, times 2 is 18, minus 3 times 5 is 15. 18 minus 15, I just get 3/5. No big deal. In number 9, if I plug in a, I'm going to get a minus a in the bottom. That's 0. I'm concerned. If I plug a in the top, I get a squared minus a squared. That's also 0. All right, so I can rewrite the limit now. Limit as x approaches a. The top is the difference of two perfect squares. So x plus a, x minus a, divided by x minus a. And that makes sense because the same reason the bottom goes to 0 is why the top goes to 0. We can cross them out. And then, even though I'm not playing around with numbers, as x approaches a, this x becomes a plus a is 2a. And that's my answer. Number 10. Number 10, we have a denominator that's becoming 0, and we have a numerator that will go to 0. So what I'm going to have to do is I know, based on the definitions we talked about, that the reason why the bottom goes to 0, which is x minus 3, is the same reason the top is going to go to 0. So I know x minus 3 is going to be a factor of that top. How and what the next factor is going to be, I have to find out. So I have to synthetically divide by that 3. The coefficients are 1x cubed, 0x squared, 0x, and then minus 27. I need to get 0 out of here. I drop the 1, I multiply, and then I add. I multiply, and then I add. I multiply, and then I add, and I get my 0. This was an x cubed. When I divide it by x, I have to depress it by 1. So this is now an x squared, so it's 1x squared plus 3x plus 9. These cancel. And now I let x go to 3. I have no problem with just plugging in 3. I get 9 plus 9 plus 9. So I get 27. This one we did in class, but I'll do it again with you. Before I can figure this out, if I plug 2 in, I'm going to get 0 on the top and I'm going to get 0 on the bottom. So it's very difficult to see how I might cancel looking at it right now. So I have to specifically change the bottom. So I'm going to rewrite this. Okay. Now what I'm going to do is I have to combine terms in the bottom. So I'm going to do that here. It's subtracting, and when I'm subtracting fractions, I need to come up with a common denominator, and that's what it is. I multiplied the x by 2, so I'm going to multiply its numerator by 2. I multiplied the 2 by x to get it to become that, so I'm going to multiply its top by x. All right? And then it becomes this. Oops. I get x minus 2 over 2 minus x, then over 2x. This piece here, which is this symbol, it means division. So I'm going to have a fraction divided by a fraction. So this is stay. X minus 2 stays. The division changes the multiplication, and this fraction flips. Right? Well, these two pieces are going to cancel out. Even though they don't look the same, they are. If they're the same two terms around a minus sign and the orders just switch, they cancel out and they leave you with a negative 1. So this is just going to turn out to be a negative 2x. Now I have no problem with x going to 2. I plug it in and I get a negative 4. So there's the limit to that one. Okay? For question number 12, I'm going to start question 12 in this video and I'll finish it in the next one. I'm just going to remind you of a couple of facts. One is, if you're not given a height function, you need one, because if I'm going to find velocity, I need basically a position function, and in this case height is going to be the position function. A position function defined this way: it's negative 16t squared plus v sub 0t plus h sub 0. All right. If you're not given a function that represents the height or position of an object, you have to use this one, and you have to know that v sub 0 is the initial velocity, and h sub 0 is the initial height. So according to this problem, my height function, or my position function, will be a negative 16t squared. It says that Galileo threw the ball up at a velocity of 64 feet per second. So that's up mean plus 64t. That's the initial velocity. Plus h of 0 is the initial height, which is 144 feet. So this is going to be your height function for the problem. Okay? Then the other piece is knowing that the velocity of some time, t sub 0, is equal to the limit as t approaches t sub 0, whatever that time is. In this question, it's t equals 5, so that's t sub 0 is 5. Then it goes h of t, which is your height function, that's the one you just came up with, minus the height of the object at t sub 0, which means take 5 and plug it in, and then you're going to divide that by t minus t sub 0. Okay, so there's the formulas that you need to be able to do this problem. In the next video, I'll start with this problem and I'll answer those 3 questions.